Concentration is the amount of solute in a given amount of solvent. Concentration is the amount of solute in a given amount of solvent. Concentration is the amount of solute in a given amount of what? Solvent. Is the amount of solute in a given amount of solvent. In bracket, you can put solvent or solution, or in a given amount of solution. Concentration is the amount of solutes in a given amount of solvent. In bracket, you can put what? Solution. Amount of solute in a given amount of solvent. In bracket, you can put what? Solution. Class, there are many ways of expressing concentration. So, first of all, you must understand that to understand concentration, we must understand a solution, composition of a solution. Class, a solution is made up of the solutes and the solvents. The solute is the solid part of the solution. The solvent is the liquid part of the solution. And when you want to find concentration, generally, how concentrated the solution will be is dependent on how much solute is there. So the amount of solutes to the ratio of how the volume of what? Of solvent. How much solvent is present. Class, if you take a pinch of salt and put it in a glass of water, and you take that same pinch of salt and put it in a full basin of water, class, the effect of the salt will not be felt in the same way in both cases. In the cup of water or in the glass of water, the effect of the salt will be felt more compared to when it's in a big container. So you can see how volume of solvent can affect concentration. So the amount of solute matters a lot. But class, that big basin of solvent, it will increase the amount of salt we put inside. It could also bring up the concentration. So in each case, we always have that the amount of solute all over volume of solvent will give us concentration. Are we following? Amount of solutes divided by volume of what? Solvent will give us concentration. Now, we have different ways of expressing concentration. If some of you have started doing the exam questions or so, you will have been saying sometimes they can ask you to express the concentration of a solution in PPT, express the concentration of a solution in PPM, express the concentration of a solution in PPB. PPT actually stands for parts per thousand, PPM stands for parts per million, and PPB stands for parts per billion. So there are different ways of expressing concentration, which we're going to be looking at now. Before we go to that, so write down subheading should be ways of expressing concentration. Ways of expressing what? Concentration of solution. Ways of expressing concentration. Ways of expressing what? Concentration. Ways of expressing concentration. We want to look at ways of expressing concentration. Class number one, we have molarity. Molarity, also known as molar concentration. Molarity, also known as molar concentration. Molarity, also known as what? Molar concentration. Class, each of the different ways have their different formula. Class, in the molarity or molar concentration, the amount of, remember that general formula, just to the general formula for concentration C is amount of solutes all over volume of solvents. This is general formula. No matter how you're expressing it, it is how much solute is present divided by how much volume of solvent is also present. But class, There will just be a little tweak when you're talking about the different ways of expressing concentration, class. For example, in the molar concentration, it's going to be amount of solute in moles. That's number of moles of solutes. Number of moles of solutes. So the amount of solute is measured number of moles of solute all over the volume of solvent. Class, this is formula for molarity or molar concern. All over volume of solvent in liters or dm cube. All over volume of solvent in liters or dm cube. So class, when they give you a volume of solvent, say 5 liters, 10 liters, and someone says 5 dm cube, 10 dm cube, you're literally talking about the same thing because liter or dm cube have the same value in chemistry in terms of measurements. So if I tell you 5 liter and I tell you 5 dm cube, there's no need for conversion because they carry the same weight in measurements. So liter is equivalent to what? Decimeter cube. dm cube means decimeter cube. Okay, this is the first way of representing concentration, expressing concern. So if you ask to find the concentration of a solution in molar concentration, class, you will need to get the number of moles of the solutes present in the solution and divide it by the volume of the solvent in liter or dm cube. Meaning that the volume of the solvent is given in another unit except this. You will need to convert. Class, the volume of solvent is given in centimeter cube. You will need to change it to dm cube. If volume of solvent is given in ml, milliliter, you need to change to liter. Now, class, number 2, and therefore, what will be the consequence of this? The unit of molarity will therefore be number of moles is measured in mole, right? And this per liter or per dm, mole per liter or mole per dm cube. And class, this mole per liter or mole per dm cube can be replaced with a big M. So sometimes instead of saying 5 mole per dm cube, you can just see 5 capital letter M. Instead of saying 5 mole per dm cube, this mole per dm cube, you can put minus as the per dm cube. I can still write it as 5 big M. Class, this is the big symbol or unit for molarity. So please take note. The second way of expressing concentration is molarity. Class, do not confuse molarity. Take note of this R and take note of this L here. Molarity. So molarity R is different from molality L. Molarity R is different from molality L. Class, let's define molality. It's defined as number of moles of solute per kilogram of solvent. Molality is defined as the number of moles of solute per kilogram of solvent. Number of moles of solute per kilogram of solvents. Number of moles of solute per kilogram of solvent. So what that means is that the formula for molality will be number of moles of solute all over mass of solvent in kilogram. So class, in molality, it is not volume of solvent, unlike in molarity where it is volume of solvent below, right? Here it is mass of solvent in kilo. So what should be the consequence? What will be the unit for molality then? Mole per kilogram. Mole per what? Mole per kilogram. I'm recording because. Any problem? You have a question? You want to pass question? Pass question. What department? Eh? Med lab. 100 level. Okay, wait. We have the third way of expressing concentration is mass concentration, also called PPT concentration. Mass concentration, also called PPT concentration. That's concentration in PPT. PPT means parts per thousand. So number 3, the third way of expressing concentration is mass or PPT. PPT means what? Parts per thousand. Parts per PPT. Concentration. Mass concentration or PPT concentration. That's parts per thousand concentration. Mass concentration or what? PPT what? Class, the formula for mass concentration, or if we have to define it first as we have been doing, if you want to understand what we have been doing, we say mass concentration is the mass of solute in grams, is the mass of solute in grams per liter of solvent, per liter of what? Solvent. Mass of solute in grams per liter or dm cube of solvent. Mass of solute in grams per liter or dm cube of solvent. Mass of solute in grams. Mass of solute in grams. SLT, you are done? Eh? Are you put on your lecture? Okay. Mass of solute in grams all over volume of solvents in liter. Or dm. All over volume of solvent in liters or dm cube. So the unit to therefore be what? Gram per dm cube or gram per liter, right? Gram per dm cube or what? Gram per liter. That will be the units. Mass of solute in grams divided by volume of solvent in liters or dm cube. Mass of solute in grams divided by volume of solvent in liters or dm cube. Mass of solute in grams all over volume of solvent in liters or dm cube. That's mass concentration, also called what? PPT concentration. PPT means what? Parts per thousand, parts per thousand concentration, okay? Now, moving forward, we have 1 minute. PPM, so we've looked at PPT, let's look at PPM. Parts per million concentration. PPM means what? Parts per million concentration. PPM, parts per million parts per million. Class, in the PPM concentration, it is mass of solute in milligram. In what? Mass of solute in milligram divided by volume of solvents in liters or dm cube. Mass of solute in milligram divided by volume of solvents in liters or dm cube. Mass of solute in milligram divided by volume of solvent in liters or dm cube. So you need to be milligram per dm cube or milligram per liter. The unit will be milligram per dm cube or milligram per liter. The unit will be milligram per dm cube or milligram per what? Per liter. Mass of solute in milligram divided by volume of solvent in liters or dm cube. And next one, we want to look at PPB. PPB concentration parts per billion. I think this should have been 4, right? This is 5. PPB concern. If you ask to calculate the concentration of a solution in PPB, PPB means parts per billion, parts per billion. And for PPB, we are going to have mass of solute in microgram. Mass of solute in microgram divided by volume of solvent in liters or dm cube. Mass of solute in microgram divided by volume of solvent in liters or dm cube. So the unit for PPB concentration is microgram. Microgram, this is micro per liter or microgram per dm. Microgram per liter or microgram per dm. That's unit for PPB concentration. Because before we start taking questions, I want to look at all possible things we'll be doing here. Let's also look at what we call mole fraction. Mole fraction. Mole is not a type of concentration, but it's something that we'll look at under these aspects. We'll look at mole fraction. So the next subheading should be mole fraction. Class, at the end of this first section, we want to rearrange our timetable again. That timetable we did that time when lecture have not started. A lot of changes have taken place. So we are going to reassign our timetable so that we can be serious with the class. We want to get back to being serious with the class, consistent with the class. Some of you, you have slacked off a lot, and it might not be your fault. There are a lot of reasons, a lot of factors. So it's not maybe I'm not blaming you. A lot of factors. It's understandable. You're doing your clearance, practicals. But thank God the stress is coming down small, because I know some people are done with chemistry practical now. Some even told me they are running off their physics too. So biology, you just started your biology, those doing biology. So very soon you run. Biology doesn't take long like chemistry. 1-2 weeks you're done with biology. It doesn't take 3-4 weeks like chemistry took. And I think 1-2 weeks we're done with biology. Then I think college students still have AAB to battle with, right? AAB 302. But we want to find a common ground where we can have a serious class during the week. I don't even want to pick all the days. I just need 3 good days during the week that we can mix it with Saturday. Are we together? 3 good days during the week, mix it with Saturday. So I want to reconfigure our timetable to suit everybody that I'm seeing in class here. So my priority will be everybody, the person you is in class here. I will not be planning time for someone that is not even around, or you're not someone that is not serious. You that came on Saturday shows you want to learn. So I should find something suitable for you. So we're going to have, after this class, we'll quickly have these 5-10 minutes where we'll just quickly look at everybody will look at your timetable, look at your schedules. Now you all have proper understanding of what you have each day now, right? You understand your free times and when you're not free. Days when you will not like to be too bothered with tutorials because they're already fixed up. So we'll look at all those things and then let's come up with something new for this second phase of the semester. Class, we're in the second phase of the semester, and the second phase is post-matric phase, exam phase. As soon as you finish matric, your focus should now be towards the exam. Because normally, according to school calendar, exam should hold next month, March, normally. But we know it will not hold because they will still shift it small. They always do that, then they'll shift it small. So highest April. So we are very close to your exam. We are very close to your exam, actually. So please, normally school calendar said March because school resumes since December. So December, January, February, March, exam should hold. The semester is 3-4 months. But we're looking at April, maybe April ending. So we have maybe 1-2 months highest. Let's just count March and little part of April. And you write your exam. So we need to enter another phase of serious preparation now. So anytime I come to class, I see 2 people, I start teaching. Thank God I'm recording it. So you will not say that you did not teach any class you registered for. There's evidence. So if I see that's why I say he came in after my class. If it's a class by so and so time, I'll be there. I start teaching. Anybody I see, I start teaching and we'll move forward. We'll not allow anybody that is not serious to be slowing those that want to learn down again. If I just see 2 people in the class, I started teaching. We have almost 200 students that have registered fully for this class. And sometimes you come to the class, you don't see less than 50 in the class. But over 200 have registered fully, all their courses, but only 50 are in class. So they don't have anybody to blame. So I'm not even talking about those that have not registered. I'll say, okay, maybe they don't have money. Some people have already registered, so money is not the problem. You have registered, you have paid. So there's no excuse. So just come and attend. And then they are not serious. So what we'll do is that we will not be waiting for anybody again. Time for cajoling students to come and learn is over. Once I come to class, we'll start. Because this exam period, nobody can draw us back. This exam period draws back. Also, we're introducing Wednesday. I told them yesterday, Wednesday. We don't need to have tutorial on Wednesday, but on Wednesday we'll be having class because Wednesday is actually a free day. Just that maybe the timing will usually wrong. So we'll look at Wednesday. We'll look at, I want to be looking at, so we'll look at that after the class. We'll reschedule our timetable and plan to be very serious. Please don't say because they are doing online now, you Physical class is the best. I'll say it anyway. It's still the best. How many data will you have to watch? How many YouTube videos? When you're in the class, you've learned it, you have learned it. It's in your book, right? You can rehearse it anytime you. This one is just for those that are working part-time. So they can't even come. Some are they're at work now. I know some of them, they message me, says I'm at work, I'm working part-time. I'm the one training myself in school. So that's why I'm doing this video for them. Or your parents are training, you don't have any excuse. You're coming to school every day. Should be here and come and learn. Should be here and come and do what? So this is just an exception for few students that cannot make it. Some worship on Saturday. Some people, today is their church, their main Sunday. So that's why we're doing this. So it shouldn't replace, that's why it's recorded, I will not come to class. It should not make everybody lazy. It should not make everybody what? Lazy. This is just an alternative for few students that they try all their best, they cannot make it. That's why we're doing this. Class, mole fraction. Class, mole fraction is defined as the number of moles of a component. Mole fraction is defined as the number of moles of a component divided by the total number of moles of all components in the solution. Mole fraction is defined as the number of moles of a component, number of moles of a component divided by the total number of moles of all components in the solution. Is the number of moles of components of a component divided by the total number of moles of all components in the solutions. Yes, yes. Let me show you. I have to pause the video. I'm recording, please. I'm recording, so please. Okay, class, moving forward. So mole fraction is the number of moles of a component divided by the total number of moles of all the components in the solution. So class, let us say a solution has three components, A, B, C. Follow me. Let's say a solution has three components, A, B, C. So for A, we have number of moles of A, number of moles of B, number of moles of C. Total number of moles in this solution will be number of moles of A plus number of moles of B plus number of moles of, will give us total number of, so the total number of moles in the solution is Na plus Nb plus Nc. Total number of moles in the solution is Na plus Nb plus N. Now, but you can be asked to find the mole fraction of one person in the solution. This is the symbol for mole fraction X. X is the symbol for mole. And the mole fraction of A is the number of moles of that component divided by the total number of moles in the solution. Look at the form. This definition is still on the board. Mole fraction is the number of moles of a component divided by the what? Total number of moles of all components in the solution. So if you have to find the mole, so you can be asked to find the mole fraction of a particular component in a solution containing other components. You could be asked to find the mole fraction of a particular component in a solution containing other components. So the mole fraction of A is number of moles of A divided by total number of moles. What will be the mole fraction of B, class? Number of moles of B divided by what? Thank you. What of mole fraction of C? NT. Can we take that question in your textbook? Bring that question from the textbook. Let's actually follow. Let's take exactly that question in your textbook. Yes. So let's actually take a question from your textbook on mole fraction. Are we ready? Are we ready? Okay, let's go. Determine the mole fraction of KCl and H2O in a solution. Determine the mole fraction of KCl and H2O in a solution. Determine the mole fraction of KCl. If you have your test, will go to page 46. You see what I'm reading there. Page 46. Determine the mole fraction of KCl and what? H2O in a solution that contains 20 grams of KCl Determine the mole fraction of KCl and H2O in a solution. Determine the mole fraction of KCl and H2O in a solution that contains 20.0 gram of KCl, in a solution that contains 20.0 gram of KCl in 200 ml of water. In 200 ml of what? Water. If the density of water is 1.0 gram per ml. If the density of water is what? 1.0 gram per ml. I'll come again one more time. Determine the mole fraction of KCl and H2O. Determine the mole fraction of KCl and H2O. Determine the mole fraction of KCl and H2O in a solution that contains 20 gram KCl in 200 ml of water. 20 gram KCl in what? 200 ml of water. Okay, let's solve this question from your textbook. So class, remind me, we need one day of the week where we do chemistry within the week to speed up our chemistry progress. We need one day during the week, apart from Saturday, I'll also be doing, so I can have 2 days chemistry per week. So I can also speed up our chemistry is still broad. There are many topics we have not touched. Thermodynamics, Lewis structure, quantum theory. There are a lot of topics we have not yet. So when we reschedule our timetable, I told you guys we'll do our timetable again. I need one day from you during the week for chemistry. So I can miss it that day and Saturday. That day and speed up our progress in chemistry. Are we together? Yes. Determine the mole fraction of KCl and H2O in a solution. Class, so it's clear that this solution contains 2 components, KCl and what? Because we want to get mole fraction, you first ask how many components are found in the solution. Because just like we defined mole fraction, so mole fraction is the what? Number of moles of a component divided by total number of moles of all the. So determine the mole fraction of KCl and H2O. They're asking us to find the mole fraction of KCl, also find the mole fraction of H2O. In a solution that contains 20 gram. So class, to get mole fraction, you actually need number of moles of KCl and we need number of moles of H2. So that when we add them together, it will give us what? Total number of moles. Follow me. So that the mole fraction of KCl now, what will it be? Number of moles of Kc divided by total number of, and what will be the mole fraction of H2O? Number of moles of H2 divided by total number of moles. Follow me, follow me, follow me. But funny enough, they didn't actually give us the number of moles of KCl. They didn't even give us the number of moles of water, H2O. So someone will be thinking that since I know the formula for mole fraction, so in the exam, they will just give me a number of mole of this. I'll just add it together and then find no. Class, they will still stress you. You see that this question requires to get number of moles of KCl. They give you mass of KCl. Class, number of mole of KCl can be gotten by saying mass of KCl divided by molar mass of Kc. Because number of moles is mass over molar. Do you remember in chemistry? The number of mole is mass divided by molar mass. Mass of KCl is 20 gram. It's been given in the question, 20.0. But molar mass of KCl is not given to you. It's something you can, what, get out. What you just say is that K, what's atomic mass of K? Potassium, 30. And Cl, 35 point. So you say 39 plus 35.5 looks like 74.5. Someone should confirm. So that the molar mass of KCl is 74 point. So the mass, number of mole of KCl will now be mass 20.0 divided by molar mass 74 point. We now give you the number of mole of KC 0.268. I'm hearing 7, I'm hearing 8. Does it mean that you've been approximated? 0.2684. Okay. 0.2684 moles. 0.2684 is the number of mole of KCl. Class, we are closer to our mole fraction. Now, we also need the number of mole of water, which is H2O, right? Class, in the water case, they did not give us mass of water. That will now say mass divided by molar mass. Class, they gave us volume of water and they gave us density of water. If you have density and volume, you can get mass. Because density is mass over volume. So the method we used to get number of mole for this guy is different from the method we used to get for the other guy. First, we need the mass of water, which must obtain from the mass of density of water and volume of water. Because density of water is given as 1 gram per mil. Volume of water is given as 200 mil. Using these two, we can say, we call that density is mass divided by volume. So if we cross multiply, what does this imply? It implies that mass equals to density times mass equals to density times volume. Follow carefully, follow carefully, follow. Class, mass of water, H2O, is density of H2O times volume of H2. Do we have density of water, H2O? Yes. Is in the question 1 point. Multiply by volume 2. So 1.0 times 200 gives you what? 200 grams. So we have gotten a mass of water. We have gotten a what? Now we can now get number of moles of water. Number of moles of what? What is number of moles of water? Mass of water divided by molar mass of. Number of moles of water is, number of moles is mass over molar mass. Number of moles is what? So mass of water, which is 200, which is what? 200 divided by what? What is molar mass of water? 18. Class, there's some common compounds elements that anytime you encounter them in any exam, you shouldn't be thinking. They are too common. They are something that you must have been using. So, someone like water, you shouldn't be thinking again. Some people like oxygen, 16. Don't be, you should have passed that level. You're a university student. If someone SS3, SS2 that, something just come, you just say potassium 39. Don't think. Did you see that they don't give up potassium? I just said 39. I did not think. You should push yourself to a higher level. Leave secondary school level. Some things, if I just tell me 82, I'll just say 18. I don't need to start something. You tell me CO2 now, I know it's 44. CO2 is 40. Because C is what? C is 12. O is 16. 16 times 2, 32. 2 plus 12, 44. Class, let me tell you, everybody can know this chemistry, but someone will be faster than you in the exams. That person that's faster is the person that has pushed himself in some small things. Let me tell you, apart from knowing the main topic, so small, those in between calculations, someone is faster than you because he already knows what you are thinking, carbon, phosphorus. Someone has known it, has written it, that is faster than, even if both of you know the full topic. So those small things are also things that delay you in exam. Brush yourself in all those things. Those small carbon, 12, calcium, 40 grams. Those are thinking. You understand? Sulfur is what? 32. Don't think. Sulfur, hydrogen, helium, lithium, beryllium, boron. Time is going. Time is. You have to start counting the first 20 before you reach sulfur. Sulfur 16 times 2, that's 32. Thank God I get them. Push yourself. I want to push you. You must be better. You can't just be at the same level. Push yourself, be better. So H2O, 18, don't think. Because H is 1 times 2, 2. Oxygen 16, 2 plus 16. H is 1, 1 times 2, 2. You're looking confused. 1 times 2, 2. What is oxygen? 2 plus 16. 200 divided by 18 is what? 11.11 mole. Class, we have now gotten a number of mole of KCl, a number of mole of H2. We are close to getting our mole fraction now. We have got a number of mole of KCl, a number of mole of H2. Don't forget, total number of mole is number of mole of KCl plus number of mole of H2 equals total number of. So what is number of mole of KCl there? 0.268 plus number of mole of H2, 11.1. Total number of mole is now what? 11.379? No. 378. 378? 11.378. Total number of moles. Total number of moles. 1, 1. Plus, total number of mole is 11.378 mole. Can we now get the mole fraction of KCl? Is number of mole of KCl, right? Divided by total number of mole. And what is mole fraction of H2O? Number of mole of H2O divided by total number of mole. So mole fraction of, because the question says determine the mole fraction of KCl and H2. So mole fraction of KCl, what is number of mole of KCl only? 0.268. Look at it here. 0. What? Divided by total, what's total number of mole? 11.37. Coming here, what's number of mole of H2O? 11.11. Number of mole of H2O is 11.11. Total number of mole? 11.37. Class. So mole fraction of KCl and H2O can now be gotten. Just divide this by this, you have your answer. Divide this by this, you have your, we would have gotten a mole fraction of KCl and a mole fraction of what? H2O. We would have gotten a mole fraction of KCl and the mole fraction of what? H2O. Does mole fraction have a unit? No. Does mole fraction have a unit? No, it doesn't have a, because it is mole divided by mole, so they cancel out. No unit. No units. Classwork. What's the mole fraction of NaCl? Write down. What's the mole fraction of NaCl in a solution containing, what's the mole fraction of NaCl in a solution containing 20.35 gram of NaCl? What's the mole fraction of NaCl? What's the mole fraction of NaCl in a solution containing 20.35 gram of NaCl? What's the mole fraction of what? NaCl. Are you there? In a solution containing 20.35 gram of NaCl and 10.21 gram of KCl. And 10.21 gram of KCl in 500 cm cube of water. What is the mole fraction? I'll come again. What's the mole fraction of NaCl in a solution containing, what's the mole fraction of NaCl in a solution containing, what's the mole fraction of NaCl in a solution containing 20.35 gram NaCl in a solution containing what? 20.35 gram NaCl and 10.21 gram KCl and 10.21 gram KC in 500 cm cube of water. In 500 cm cube of, in the question they say we should take density of water as, take density of water as 1.0 gram per cm cube. They also give us some other things. Molecular mass of NaCl is 58.45. KCl is 74.5. And H2O is 18 gram. 18. So they give us all this as hints. They give us all this as what? As hints. Class, this is a classwork actually, so I believe you are making an attempt already. So number of mole of KCl plus number of mole of NaCl plus number of mole of water. Class. There are three components in this solution. Anytime you have to find mole fraction, you need to determine first how many components are in the solution. How many components are in the... That's the first thing you need to ask yourself. There are three components inside this solution. We have KCl, we have NaCl, and we have H2O. Number of mole of KCl plus number of mole of NaCl plus number of mole of H2O equals total number of... Now, what is the mole fraction of what? NaCl. So they are only asking us to find the mole fraction of NaC. So mole fraction of NaCl, class, is what? Number of mole of what? Class, the mole fraction of any component is number of mole of that component divided by total number of moles. So we just need the number of mole of NaCl. They say, what is the mole fraction of NaCl in a solution? They didn't ask us to find mole fraction of any other person, right? Just NaC. Of class, we first need to find total number of moles. Do we know the total number of moles? No. How do we get total number of moles? We need to find number of moles of KCl, number of mole of NaCl, and number of mole of H2 and add them. So let's start with number of mole of KCl. What is the formula for number of moles? Is it not mass over molar mass? So that is mass of KCl divided by molar mass of... Because formula for number of moles is mass over molar mass. Formula for number of moles is mass over molar... That is mass of KCl divided by molar mass of KCl. Our mass of KCl is what? 10.2. Molar mass of KCl, they are already generous enough to give us. It's 74.5. Who has done the math for us already? 0.137 mole. Now, number of mole of NaCl is mass of NaCl divided by molar mass of NaC class. Mass of NaCl is given already. Past questions. Past question. What department? Geology. You need two. Year two. Year two. Wait, I'm coming. Mass of NaCl is 20.35. Molar mass of NaCl is 58.4. 20.35 divided by 58.45. Who has done the math? 0.0.34. 0.348 mole. Good. Class. It now remains number of mole of H2O. Is mass of H2O, which we don't know, I'm sure. All over molar mass of H2O, which we know because here, 18. Class, how do we get mass of H2O? From the previous question, you see, because we have practiced a previous question, you now know what to do here, right? This is what solving past question does for you. You have solved a previous question. So when you get to the exam, that question is not surprising you again. Because no matter how much you read, and you just say you have read, you don't want to take examples, you don't want to take questions. When you get to the exam, some questions will still catch you off guard if you've not practiced enough questions on that topic, even if you have read that topic. Because it's one thing to read the topic, it's one thing to be able to answer questions on that. Because there's a way lecturer can twist a question. For something you have read, you still miss it. If you have not practiced how the line of question, every topic has a line of questioning, the way they question you on that topic. You have to go and practice it with previous exam questions. Go to previous exam questions, see how they have questioned them on that topic. So that you will not be surprised in the exam, even if you have read the topic. Class, Mass of H2O is simply now density times volume, right? Because we have done before. That's 500 times 1 is 5. So my mass of H2O is 500 grams. I don't even need to go. And molar mass is 18 is here, right? So 500 divided by 18. 27.777. How have we been doing? Is it 2 decimal place so far? 3 decimal place? 778 mole. Class, when you are solving, it's good for there to be consistency in your values. If you have started with 3 decimal place, 0.137, 0.348, then let's keep it in 3 decimal place, 27.778, so that your answer can be consistent. Having gotten our 3 number of moles for the 3 components in the solution, we can now add them together to get the total number of moles. So our total number of moles is number of mole of KCl, which is this, 0.137. Number of mole of NaCl, which is this, 0.348. And number of mole of water, which is 27.778. Who has done the math? 28.263 mole. Total number of mole is 28.263 mole. Now, which of them will we have to find the mole fraction? NaC is number of mole of NaCl, which is what? Number of mole of NaCl is 0.348, right? Divided by total number of mole, 28. So 0.348 divided by 28.2. Who has done it already? 0.012. 0.01. Does it have a unit? No. Mole fraction does not have a unit. Find the molar concentration of a solution containing 8.56 grams of hydrogen chloride. Find the molar concentration of a solution containing 8.56 grams of hydrogen chloride in 500 ml of solution. In 500 ml of solution. Find the molar what? Concentration of a solution, right? Find the molar concentration of a solution containing 8.56 gram. Containing 8.56 gram of hydrogen chloride. Of hydrogen what? Chloride. Class. Don't give one course importance over the other. Some of you now, you have done physics completely because that physics does not have manual, it doesn't have anything. Or chemistry. Like now, I was almost pressurized to just do my 120 today because of that workbook pressure. But why they are giving you all those assignments, don't allow it make you forget your preparation for the main exams. All this workbook, everything you are feeling is 30 marks. Even if you score 30 over 30, you have not passed the exam, it's TF. There's still a main exam coming up. So any assignment they are giving you, any workbook they are asking you to fill, don't allow it to derail you from your plan of exam. The exam is the ultimate goal, eventually. That's why sometimes there will be pressure, workbook, this, that. I will still fix normal class, physics. There was that trial last week. With all that pressure, I was teaching physics. I just want to go find the physics. And thank God we did up to chapter 5 last week, physics, before we say, okay, let's go to chemistry and maths. So please, balance all your courses. Your FSB, biology is there. Those doing AAB, balance, let them be balanced because it's no good passing just one course because that's where there's pressure now because they give one serious assignment. Some of you, any course they give a serious assignment, that's where your brain will be on that point. You will leave every other one. When they give assignment, say you now rush it again. You don't have a consistent this and nothing should shake. This is my timetable. If they give assignment, I will do it, submit. But I continue my pattern for exam. You should have a normal pattern, reading pattern or whatever. Plan for your, that nothing should shake it. No assignment they give, no test, anything should shake that plan. This is how I do for my exam. I'm going to read all my courses. My GS is there, my FSB, my maths, my physics, chemistry. For exam, because you must pass all your courses. Because once they give one wicked assignment in one course, you just dump all your courses and focus on that one. Hey, it's math that is something. No. Yes, it's important, but don't now give it all the attention and forget others. It must be balanced. There must be what? That's why today I said, no matter what, so some people are shouting, what book, this, what book, I must do chemistry today. We have not done chemistry this week. Must do chemistry. Must be a balance. So after chemistry now, we'll go to maths. It's like that. There must be a what? Balance. Also your physics too. We're going to continue it. So that's why after this class, we're going to reschedule our timetable again so that it can favor at least or benefit us to our advantage. So please take note. Now, I have 2 questions here for you. The first one I just read, I said, find the molar concentration. Find the molar what? Concentration of a solution containing 8.56 gram of HCl in 500 ml of solution. In 500 ml of solution. We are told to take H as 1.01 and take Cl as 35.45. Now, second question. Second question, this is question 1. Question 2 now. A solution of Na2SO4 has a molarity of 0.450. A solution of Na2SO4 has a molarity of what? 0.450. How many grams of Na2SO4 is contained in 600 cm cube of solution? If the density of water is 0.987 gram per cm cube. Take Na as 23, S as 32, O as 16. Take Na as 23, S as 32, O as what? 16. Third question, express this from your textbook. The concentration, express the concentration of 0.02 gram of CaCO3 per 200 ml of solution in PPT, PPM, and PPB. In PPT, PPM, and PPB. Express the concentration of 0.02 gram of CaCO3 per 200 ml of solution in PPT, PPM, and PP what? PPB. Class, these three questions, if you started this class today with us this morning, you should be able to solve them. If you started this class with us this morning, you should be able to solve them because looking at this first one is molar concentration, which we've taught under molarity. Under what? Molarity. The second one, a solution of Na2SO4 has a molarity, also molarity, which I have taught you. Ways of expressing concentration. If you missed the beginning of the class, it's being recorded. I'll post it. If you have registered for our class, it will be posted for you so you can access it. And this is the third one. Class, let's take it from the first one. Find the molar concentration of a solution containing 8.56 gram of HCl. Class, so the mass of HCl is 8.56 gram. Volume is 500 mil. Class, find the molar concentration means molarity. Molar. Class, molar concentration, the formula for molar concentration is what? Number of moles, right? Of solutes all over volume of solvent in what? In liters or Class, our volume of solvent in liters? No. It's in ml, mil. Is in what? Mil, milliliters. Therefore, we have to change from mil to liter. We have to change from mil to what? And to go from mil to liter, we divide by 1,000. We divide by what? To go from mil to liter, we have to divide by 1,000. Also, we need to get number of mole of the solute. The HCl is the solute. The volume is 500 cm class. We need to get number of moles of solute. We have to find the mass of HCl divided by the molar mass of HCl, which is 36 point. Okay, we're using this 1.01 plus 35.45. Let's use, if they give you something big, just use the one they gave you. HCl means H plus Cl. 1.01 plus 35.45 will give you what? 36.46. So 36.4. What am I trying to achieve here, class? I'm trying to find the number of mole of HCl, right? I'm trying to find the number of mole of HCl because to get the molar concentration, I need number of mole divided by volume. God, they gave us mass of HCl. I divided by the molar mass of HCl to get number of moles of HC. What is 8.56 divided by 36.45? 36.46, sorry. Because how do we get 36.46? 1.01 plus 35.45, right? 36.46. So what is 8.56 divided by 36.46? 0.23. Is it 4 or 5? 5 approximately? 0.235 mole. This is the number of mole of HCl. Number of mole of HCl, 0.235 mole. Volume of HCl is in mil. Convert to liter by dividing by 1. Please, anytime you want to go from mil to liter, divide by 1,000. Class, your molar concentration, the volume should be in liter, not mil. The volume should be in liter, not mil. So, if you are giving your volume in mil, do not use it to convert to liter. Convert to what? By dividing by 0.5 liter. Now, we have mole and we have liter. We cannot get our molar concentration, which is number of mole of solute, which is 0.235 mole, divided by liter, 0.5. Who has done the math? 0.470. 0.470 mole per liter. That's the molar concentration for the first question, class. Anytime you have to find molar concentration, it is number of moles divided by volume in liters. Number of moles divided by volumes in what? In liters. So we're done with the first question. Second question is still here. And it said a solution of Na2SO4. A solution of Na2SO4 has a molarity of 0.450. Class, they are giving us the molarity already. How many grams of Na2SO4 is contained in 600 cm cube? It's contained in 600 cm cube of solution. If the density of water is 0.987 gram per cm, how many grams of Na2SO4 is contained in 600 cm cube of solution? Class, what are the parameters given? We have the molarity. Molarity is 0.450. We have the volume, but the volume is not in the correct unit. The volume is in cm cube. We need to change it to dm. Class, cm cube is similar to mil when it was a mil here. Class, cm cube and mil are similar. We have changed to dm cube by dividing by 1. We have to convert from cm cube to dm cube by dividing by what? 1,000. So 600 CNQ divided by 1000 will give us what? 0.6 dm. Class, never use your volume in cm cube, convert to dm cube, especially when solving for concentration, especially when solving for what? Concentration. SRT students, the lecture over. Is your SRT lecture over now? It's over? Okay, we're waiting for you. We didn't want to do the math until you came. So, now, class. Molarity, same thing as molar concentration, is number of moles all over volume. Is number of moles all over what? I need to get number of moles cross. So my number of mole is molarity times volume, right? My number of moles, molarity times, I think it should be done here now. Class, if I get my number of mole, I can now get the mass. How many gram? How many gram means mass, right? But let me get the number of mole first. Let me get number of moles. Number of mole is molarity times volume. What's my molarity? 0.450. And what's my volume? 0.6. So what's 0.450 times 0.6? What's 0.450 divided by time multiplied by 0.6? Did I say divided by? 0.450 times 0.6. 0.270 is my number of mole. Crap, but is that what they asked me to find? They said how many grams? How many grams means mass? M. Crap, number of mole is mass, small m, all over molar. I'm looking for this small m. Nobody wants to find big M. Big M is something you can easily find. It's a constant. How many grams of Na2SO? So I'm looking for mass. I'll cross multiply. My number of moles times molar mass will give me how many grams. My mass, how many grams means mass, right? Is number of moles times the molar mass of Na2SO. What's my number of moles? I just have it here, right? 0.27 multiplied by the molar mass of Na2 what? Who has done it for us? Na2 is 23 times 2, 46. S is 32. Everything is 142 gram. So 142. Class, Na2SO4, find the molar mass. They gave us Na as 23. So 23, but Na is occurring twice. So 23 times 2, 46 plus S is 30. Look at S is what? Plus O is 16, 16 times. Add everything up, you have 142. So my mass, how many grams? I'm about answering the question now. Is mass is number of moles times molar. Number of moles is 0.270, right? So I knew what I was doing when I was finding number of moles here. All together? 0.270 times 142 is what? 38 point. 38 point what? 38.35. Okay, if it's 4, if it's 5, write whatever you got in your book. Grams. Write whatever you got in your, is a free word, is a free. 38.34 gram is the, how many grams? That's the answer to number 2 question. Quickly. We have one more question before we go to dilution. Before we look at titration and we look at dilution. In number 2 question, it was not, you were not used it for anything. It's not everything they give you in a question you use. Now, class, let's. One more question. Express the concentration of 0.02 gram. So mass is 0.0 per 200 ml. Volume is class. Anytime you see 200 ml and you want to solve concentration, change to liter immediately. If you see 200 ml or you see cm cube, know that something is wrong somewhere. You see your volume in ml or cm, just know something is wrong. Change by dividing by 1,000 and you have a 0.2 liter, 0.2. Class. Let us solve now. Express the concentration of 0.02 gram of CaCO3 per 200 ml. We have changed 200 ml to liter. Class, in PPT means mass of solutes in grams all over volume of solvent in liters. So our mass of solutes is in grams already, 0.02 gram. Our volume of solvent, 0.2 liter. We can get PPT. Please take note. When it says you find the concentration of a solution in PPT, it is mass of solute in grams, and our mass of solute is already in grams, 0.02. 0.0. Take it serious. This one is from your textbook. Take it serious. When they say express in PPT, those that came late, this question almost covers the things we did before you came in, which is PPT, PPM, and PPB. So if you follow this solving I'm doing, you cover up what you missed while you were not here earlier. PPT, I taught them PPT, PPM, and PPB. So when PPT is mass of solute in gram, all over volume of solvent in liter. Another name for PPT is mass concentration. The mass of solute in gram is 0.02. Volume of solvent in liter is 0.2 liter. So 0.02 divided by 0.2 looks like 100. Someone should check. 0.02 divided by 0.2. Is it 0.1? 0.02 divided by 0.2 is 0.1. Okay. 0.1 ppm. So we've gotten our, PPT, PP. So we've gotten our PPT, mass or PPT concentration. Now, the next one says we should find PPM. PPM, formula PPM is mass of solute in milligram divided by volume of solvent in liter. Mass of solute in milligram. Class, must change this mass from gram to milli. We have to change this mass of our solute from grams to what? Milligram. We're going to change this mass of our solute from gram to what? Milligram. How do you convert from gram to milligram? Class, in case we are not around, ppm is mass of solute in milligram. Mass in what? Over volume in liters. Our volume is already in liters. We change from mil to liter by dividing by 1,000. We have changed our volume from mil to what? Liters by dividing by 1. So our volume is 0.2 liter, but our mass must be changed to milligram. Currently, our mass is in gram. Class, from gram to milligram, multiply by 1,000. Multiply by what? From gram to milligram, multiply by what? So 0.02 gram to milligram is multiplied by what? 1,000. What would that give you? 20 milli. 20 what? Milligram. I hope we all came with our Math 120 workbook. Some people have you submitted already? You have submitted 120. Have you submitted your 120? No. Okay. They also gave you 110, right? When are you submitting 110? Thursday. Okay, no problem. For 110, we'll fix a day during the week. We'll fix it here so that everybody must be free. We'll fix a day that is free for every. See how we can find out if that's possible. If it's not possible, then we'll fix a day that is free for most people. The perfect scenario will be that free for everybody. But if it's not free for everybody, then free for most. But we'll first try to achieve a day that is free for everybody. If we can't do that, then we'll find a day that is free for most, at least 80%. Can't, but we'll try so that we can do the 110. Today we came for 120. 120. 120. Now, 20 milligram divided by what's the volume in liters? 0. So you have 20 milligram divided by 0.2 liters. That will give us what? 100, right? 100 ppm. Plus, this is the concentration of the solution in ppm, parts per million. This is the concentration of the solution in ppm, parts per million. So you find your mass, they'll give you your mass, but you change it to milligram by multiplying by 1. And your volume should be in liters. They also ask us to express the concentration in PPB. PPB means parts per billion. So coming again, PPT is parts per thousand, PPM parts per million, PPB parts per B. For PPB class, it is mass of solute in microgram. Micro divided by volume of solvent in liter. That's PPB. PP what? So if you ask to find the concentration of a solution, please, where is that noise coming from? If you ask to find the concentration of a solution in PPB, you must convert your mass to microgram. And you multiply. How do you convert from gram to microgram? Multiply by 10 raised per 6. Multiply by 10 raised per, or multiply by 1 million. Or multiply by 1 million. So we're going to have multiply by 10 raised per 6 or multiply by 1 million. So our gram mass is in 0.02 gram to microgram. What will you do? Multiply by 10 raised per. That will be what? 20,000 divided by what's volume of solvent in liters? 0.2. PPB is microgram per liter. No, this is milligram mg. Microgram is this microgram per liter. 20,000 divided by 0.2 is what? 100,000. So class, the PPB concentration solution is 100,000 PPB. 100,000 what? PPB. You must convert your mass from gram to what? Microgram. How do you do that? Multiply by 1 million. Multiply by what? From gram to microgram. Multiply by 1 million. Right, and dilution, quickly. Dilution. Hello? Yes. PSO. PSO. Come to PSO. Where are you? Let me direct you. Where are you now? Ofrima. Okay, okay. Just leave Ofrima and come out of Ofrima first. Do as if you are going towards Arena. From Arena, you do as if you keep coming again. You do as if you are going towards, do you know basic unit? Do you know STC? You know STC? Do as if you are coming towards STC. Before you get to STC, ask someone that you're looking for PSO. They'll direct you. PSO is before STC. If you are coming like this, welcome. Yes. Dilution is the process of adding a quantity of solvent. Dilution is the process. Dilution. Dilution is the process. Who's calling me? Who's calling me? Yeah, multiply, multiply. Dilution is the process of adding a quantity of solvent, in bracket, put water. Dilution is the process of adding a quantity of solvent, in bracket, put water. Dilution is the process of adding a quantity of solvent, in bracket, put what? Water. See if you can fill this thing up for me. I don't know if there's anything inside. To a concentrated solution, in order to obtain a new concentration of the solution. In order to obtain a new concentration of the what? Solution. I'll come again. Dilution is the process of adding a quantity of solvent. Dilution is the process of adding a quantity of solvent. Dilution is the process of adding a quantity of what? Solvent to a concentrated solution in order to obtain a new concentration of the solution. In order to obtain a new concentration of the what? Of the solution. Class, when you dilute something, have you ever tried to drink Gary or something with your friend before in the hostel? When we were in school back then, we'd take Gary. If your friend wants to come and join you, what do? You add, why are you adding water? So that you go reach every, and then when you add water to the Gary, you're sacrificing for your friends, right? A friend in need is a friend in what? You're sacrificing for your friend because you are sacrificing the quality of your African salad. Because at the end of the day, you already bought the required amount of sugar, milk, granules, and all other obstacles involved in the process. But your friend comes in. I remember then we used to stay in hostel. Once you are cooking and you see people washing their spoon, just know that it's your food they are planning. Are we together? It's you that is cooking, but people are washing plates. Ah, guy, you're not cooking it. Why are you washing plates? So when they join you in the drinking of the solution, it might be conflicts. Maybe you bought milk, 2 sachets of milk for your conflicts. Your friend, 2 of your hostel friends wants to join you. Then you know that you can't eat alone now. You know what I'm talking about, right? Maybe you're already cooking beans and you see people arranging their spoon and they just come to keep you company. Yeah, people that have not talked to you before in the hostel, they just come to keep you. Elisha, how far now? Which one be how far? Who are you guys? How together? Say, no, just cook now. We're there. Say, okay. So when the food is ready, they now bring out their spoon. And so you added water to the solution, and the solution will reduce quality, the concentration. You have a bigger solution, but a lower concentration. So what dilution does to a solution is that it increases the overall volume. What dilution does to a solution is that it increases the overall but reduces the concentration. It increases the overall volume, increases the concentration. It increases the volume and reduces the concentration. Dilution reduces the concentration, and increases the volume. So there's more solution, but it's lesser concentration. When we were kids back then, there's one very expensive juice our mom used to buy. So she would maybe serve everybody small, like Holy Communion, and cover the rest in the fridge. And she knows the level where the drink stopped. But what she doesn't know is that she has some chemistry students in her home, my mom. So when she goes out, nobody should touch this drink till I come back. Yes, mommy. When she goes, we serve another second layer of what communion to ourselves. Then what we do? We even add jara for ourselves. The mom will be thinking, Jesus will increase this wine. He turned water to wine. We together, we turn wine to water. So she come back, but when she not taste it, she drink it. What? All of us are not smiling. She doesn't know what's going. Class. So dilution, there's what we call the initial concentration and the initial volume. And we have the final concentration and the final This is the dilution formula. Class, before you added water to the solution had an initial concentration and it had an initial volume. After addition of water, expect the concentration to reduce, but expect the volume to. So C1V1 equals to C2V2 is the formula, dilution formula. Dilution. C1 represents initial concentration. V1 represents initial volume. C2 represents final concentration after water has been. And V2 represents final volume after water has been. But they usually ask you, the common question is find the diluting volume. Diluting volume is the volume of water that is added to a known concentration of a solution. Diluting volume is what? Volume of water that is what? Added to a known concentration of what? Solution. And how do you find this? The final volume minus the initial. If I was too fast, let me come again. Diluting volume is the volume of water that is added to a known concentration of a solution. Diluting volume is the volume of water that is added to a known concentration of a what? Of a solution. College students, I'll soon be rounding up chemistry. I want to go into Math 120 very, very soon. So please take note because there's a serious issue in Math 120. I was telling some of your colleagues, I said, the most failed course, there are two. In my carryover group, we have two courses that people failed. When you join my carryover group, I'll create a poll. You say, who they join? I'm not talking about you now. You guys say who they join. I'm not talking about. I said when you join, not you. When they join our carryover group, we usually I like to ask, what course was failed the most? What course was what? So I do a poll. Maybe I'll screenshot the poll and send to you too. So you see the course that is failed the most. It's Math 120 and chemistry too. Chemistry is, I don't know why. Chemistry, why is chemistry dangerous? That they won't give you option. It's subjective. So you will not know if you are correct or, in OBJ exam, sometimes when you solve and you don't see your answer in the option, you say, thank God, though, I don't pick nonsense. When you solve and your answer is in the option, your wrong answer is in the option, you're in problem because you think it's correct. Sometimes by you not seeing your answer in the option, they're helping you, you go and solve again. But in a subjective exam, there's no option. So your first answer you got, you will never go and cross-check it. You just write it there. And you will never know till the result comes. For example, they ask a question, which scientist actually discovered proton? Who discovered proton and what year? Last said they surprised some your colleagues. We were busy doing calculations in chemistry. People were taking calculation, balancing equation. They started asking some funny theoretical question in chemistry. Who has opened the passage of last set? You see the one of them is Laviosa. One of them, R.A. Millikan, the oil drop experiment. Things that you will not open your book to read. Those in between, that is atomic theory, the modification of that is atomic theory. Remember that when isotopy started coming into picture, the radioactivity, the non-stoichiometric elements. There are some elements that don't fit into the normal elements. That thing discovered in the modification. If you have read chemistry deeply, forget this calculation. They are the deep theoretical background of chemistry. If I start changing, it's boring. It's a boring aspect. Have you heard of James Chadwick? Rutherford? J.J. Thomson? That's what they were asking. Who discovered this? Which scientist? Give two scientists that were dash, and you just see dash, no option. If it's option will remind you if you have read it before. Something you have read before in the textbook. If they put in the option, you remember, right? I've seen this one. Now B, I don't see B before. Or something you have, but when there's no option, nothing to remind. So they are working from a blank memory. So that's what made we had a lot of F's in chemistry and Math 120. We had so many F's. Tomorrow Sunday, I have a carryover class, my first carryover class for this year. Yes, if you are staying in school, come around there Sunday, 3 p.m. with a carryover class. You see, but please don't come. So you're not so why you tell them now. Leave them. Please don't come. Don't. Please, it's not your business. Some of them is not as if they were not intelligent. It's just some things that made them fail. Please don't. It's not good. It's not good. It should be a private something. So please, in fact, I'll change the venue. Don't come. But we have a serious carryover class tomorrow. Someone say how much? Are you a carryover student? So the thing what we want to do for them is they don't have time. Year 2, year 3 don't have, because you are battling with your year 2 pressure. You now come back to 100 level. That's why I don't want some of you to go through, because it's stressful. So people that cannot come to school on Saturday, they're not coming on. I don't come to school on Saturdays. I'm stressed out a bit. I don't like stress. But they are coming on Sunday now. Guess what? It's not me that fixes it. They are the one that, so we don't have time during the week. Sunday will come. It's not me that fixes it. I mean, students fix class. Me, I will go. I can teach any. I don't mind teaching any. So 3 p.m. serious carry. I want to first do Math 120 for them. Math 120. So please, this is how. Do you know everything I'm saying? I said it last set too. Everything I'm saying now, I said last set, but some people still failed. Whether we like it or not, no matter how much you cast and bind, this F already is sure. Everybody cannot. Someone must make sure that person is not. So everything we need to do to pass, do it now. Class. So diluting volume is the volume of water that's added to a solution. V2 final volume minus V1 initial volume. Calculate the volume of water needed to dilute. Calculate the volume of water needed to dilute 200 ml. Calculate the volume of water needed to dilute 200 ml. Calculate the volume of water needed to dilute 200 ml of 0.1 m NaOH. Calculate the volume of water needed to dilute 200 ml. Calculate the volume of water needed to dilute 200 ml of 0.1 m NaOH to obtain 0.01 m NaOH. To obtain 0.01 m NaOH. Calculate the volume of water needed to dilute 200 ml of 0.1 m NaOH to obtain 0.01 m NaOH. Calculate the volume of water needed to dilute 0.1 m NaOH to obtain 0.01 m NaOH. So what water was needed to dilute? When you hear dilute, just what should come to your mind? Dilution formula. Dilution what? Class, you now ask yourself, what's the C1? C1 means initial concern. So dilute 200 ml of 200 ml, that was the initial volume V. Initial volume V1 is 200 ml. Of 0.1 m NaOH means initial concentration is 0.1 m. So C1, right now, C1 is 0.1 m. V1 is 200 ml. Class, this is the only place you're permitted not to convert ml to liter. You don't need to convert ml to liter here. Are we together? Initial concentration, C1, 0.1. Initial volume, V1, 200. Final concentration, C2, 0.01 m. To obtain what? 0.01 m. To obtain 0.01 m. To obtain 0.01 what? M. Class, did they ask you to find the final volume? No. No. Calculate the volume of water needed. Class, volume of water needed is diluting volume. Class, take note. That's what I want to correct. That's why I gave this question. Many students will think, it's only V2 that I don't know. So that's what I'm looking for. No. Class, what you're looking for is diluting volume. But diluting, to obtain diluting volume, you will say V2 minus V1. To get diluting volume, we say V2 minus V1. To get diluting volume, we say V2 minus V1. But we need to get V2 first, right? So that we'll now say V2 minus V1. You get diluting. So class, let us get V2. How do you get V2? You say C1 V1 equals to C2 V. C1 V1 equals to C2 V. What's our C1? 0.1. What's our V1? 2. What's our C2? 0.0. We're looking for V2s. We are looking for V2. Class, we'll make V2 squared of the divide both side by 0.01. So 0.1 times 200 divided by 0.01. 0.1 times 200 divided by 0.01. 2,000. So my final volume is 2,000 mil, class. But this was not the volume of water that was added. They say calculate the volume of water needed to dilute, right? What is the volume of water that must have been added? Is the final volume minus the initial. It's called the diluting. So my diluting volume is V2 minus V. What's V2? 2. What's V1? 2. So 2,000 minus 200 will now give us what? Class, 1,800 mil. 1,000 what? Is my diluting volume. Is my diluting volume. Class. The next thing we want to look at, right, and limiting reagents. Limiting reagents. I'll giving you 2 courses today. This chemistry and then math 120. Then math 120. Class, I'm giving you short things, short topics that you like bringing in the exams. Like I said earlier, don't concentrate all your effort in only one course. No matter how well you do in one course, it will not affect what you do in another course. You score 98 over 100 in math 120. And you now got 20 over 100 in chemistry. They will not say, sir, collect more for my math and put in chemistry now. No. They won't do that. Limiting reagent, class, write down. Limiting class. Have we done limiting reagent before? No, we have not. We have not. Okay, good. Class. When 2 reactants are reacting, there is a reactant that is first consumed or first used up. When 2 reactants are what? Reacting. There is a reactant that's first used. That reactant that's first used up is the limiting. Follow me. No noise. Class, when you buy provision in the... I'm recording. When you buy provision in your home, you buy milk, you buy Milo. Notice that they don't finish at the same time, no matter how well you manage them. There's one you like over the... Which one usually finish first? Tell me the truth. Confess. Is it milk? So your milk usually finish first for your Milo, or your Bonvita, or your whatever, Ovaltine. Class. Why does milk finish first? Okay. I did record next time. Your milk usually finish first because it has many uses. For Gary is there, right? Cocoa oats, golden morn, custard, tea, even baking, right? Sometimes you bake, you put milk. Good. For licking. So, class, you can see, same thing applies. Please transfer that same knowledge. As you're happy like this about milk now, transfer the happiness into limiting reagent reactions. If you have a reactant A and B, follow me. A plus B reacts to give C. Follow me. A plus B reacts to give what? C. Class, A plus B will keep reacting until one of the reactant is consumed. Class, the reaction does not stop until one of the reactants is no longer available. As long as these 2 are still available, reaction continues. But as soon as one of the reactants is finished, then the reaction stops. Now, class, that person that finishes first determines how far the reaction goes. Because the time he decides to finish is the time the reaction will also stop. And once the reaction stops, the product is no longer formed, right? As soon as the reaction stops, this product C is no longer formed. Therefore, the limiting reagent also determines the maximum amount of product that can be obtained. Follow me. The limiting reagent also determines the maximum amount of product that can be obtained from a given chemical reaction. The limiting reagent also determines the maximum amount of product that is obtained from a given chemical reactions. Because that person that finishes first is called the limiting reagent. The person that is still remaining is called the excess reagent. Class. So we have limiting reagent and we have excess. Class. In the exam, you could be asked that two reactants reacted with each other to give a particular product. Determine the limiting reagent. Class, there are steps that you can use. There are well-known steps that you can use to determine which of the reactants will finish first, even without carrying out the reaction. Even without carrying out there are well-known steps that you can use to determine who will finish first among these two, even without carrying out the reactions. This school is really stressing our SLT students. Because honestly, I don't see why someone should be doing 13 courses. I don't see why someone should be doing what? Some of you don't know that you're enjoying. You. Some of you are doing 8 courses, you are complaining. Go and ask any SLT student how is life. They are stressing them. I don't like it. I was at their venue today. Classwork, this, that, and they have to carry drawing board up and down. It's not enough that you are going to class normally. The extra stress of carrying drawing is stressful.